So thank you very much for attending this webinar titled Functional Programming Without Lambdas. And these are the two guys that are going to present today. On the left side, you can see me, Johan Haleby, and on the right side, you see my colleague, Mattias Severson, and we work at a consultancy company in Sweden called JayWay. And you can see on the pictures that we're really happy to present here. And the agenda for this presentation will look something like this. So we will start off with a brief introduction to functional programming. We won't go too deep into the theoretical concepts of what functional programming is all about. Rather, the main emphasis on the presentation will be on the comparison between the three different frameworks mentioned here, functional Java, Lambda J, and Guava. So we hope that you have some basic knowledge about functional programming, and even if you don't, we think that you will still have a pretty decent understanding after we finish the presentation. So and in the end, we'll have a short summary. And just a little disclaimer, because what we will present here are our own personal opinions, so it's not a scientific study or anything like that. So you may be wondering why we're even talking about functional programming in Java in the first place. Is it really interesting for us as Java developers? Well, if you look at other programming languages out there that are popular, like Groovy and JavaScript and Scala, they all seem to have some sort of functional paradigms built into the language. So the question is perhaps a little reversed. Why shouldn't it be interesting for us as Java developers? And also, Oracle will ship Lambdas in Java 8. So that means that Java will pretty soon have some functional programming constructs in the language as well. So we should learn it, I think. And even though you won't have the opportunity to use Java 8 as soon as it is released, it will be released the next spring, hopefully, there is still value in learning a bit about functional programming. And if you work at a large organization, perhaps, it will take some time before they adopt Java 8, even though it's released. I mean, it can take years for larger organizations. So until then, I think that it's really important to, have some sort of understanding about what functional programming is and how you can use it, because I think it will be used more and more in the future. So one of the benefits of using functional programming is that it allows you to focus more on what you need to do to solve a particular problem and not how you go about to solve it. And here you can actually see an example. So on the left side, you can see an example of what's usually referred to as imperative programming. And this is what we're kind of used to in Java. So this describes, or the program is described by a sequence of statements that changes the program state, whereas on the right-hand side, you see this declarative programming that simply describes the computations that should be performed, not how they're actually performed. So as the example shows here on the left side, you do a standard Java for loop, and you iterate over a collection of persons. And for each person, you get this person out of the list and you send the person instance to the printline method. And the person will be printed to the console. So if you compare that with the example on the right-hand side, then we pass a reference to the printline method to the for each function instead. This means that we don't need to do this iteration ourselves. We let someone else do that for us. So this is, of course, a very trivial example, but you can imagine, like, once in a while, something like this actually goes wrong, and, it's really unnecessary. Maybe you start your iteration with I equals 1 instead, accidentally, and this is just stuff that, it shouldn't happen. And also, if you look at the right example here, or the example on the right-hand side, it's probably simpler to understand as well. So when we talk about functional programming, there are always these kind of patterns that comes up. And Mattias will now take over the microphone and talk about these patterns, or some of these patterns.
Yeah. Hello and welcome, everyone. This is Mattias. The first concept that we would like to introduce is the notion of mapping. Sometimes it's referred to as transforming. And the idea is that you have one object and you would like to transform it into another object. So for example, you have the persons here on the left-hand side and a collection of persons using this mapping function in the middle that for each person get the age of a person. And now you can see on the right-hand side that from a collection of persons, we now have a collection of integers. And the integers represent the age of each person. So that is the mapping that we use to transform, in this case, person to an integer representing the age. The next concept that is very common with functional programming is filtering. So yet again, we have a collection of persons, and for some reason, we're only interested in a subset of all the persons here. In this example, you see that the function in the middle is a Boolean function that when we check the age of the persons, and if a certain person is older than 20, this function will return true. And for every true result, that means that we will keep the reference to that person after the filtering operation. And consequently, if the person is younger than 20, we choose to discard it because the result of the return value will equal false. And these functions sometimes also called a predicate function. So when evaluating this filter function, you can see that from having only 4 persons, we now only have 2 persons, and those are, of course, older than 20 years. Next example of a functional program is the example of reducing. It's a concept where you have a collection of objects, and somehow you would like to extract only one of them. Or you can take the object in the collection and transform it into another object. If you have used other programming languages, this function is sometimes called fold. It can also be called fold left or fold right, depending on the implementation details. And typically, you will use this kind of operation when you try to find the minimum value of a collection, maximum value, calculating the average. It can also be known as an aggregate function. So imagine here you see 3 digits, 2, 4, and 3. And if you apply a fold operation or a reduce operation on these collections with 3 digits, and in this particular example, we use the add method. So you can imagine that you take the first 2 elements in the list, 2 and 4, and they will equal 6. And then you add, after that, each element that is left in the list. So you have 6 and you add 3, that will equal 9. And if you continue on iterating across the list. In this example, as a result, we'll see that the sum equals 9 because we only had the 3 elements.
So what options do we have for Java if we want to, start experimenting with functional programming today, if we don't want to wait for Java 8 to arrive? Well, of course, you could use another programming language, and well, that could be pretty worthwhile to check that out as well. But if we want to use Java, there are also some options for us, even today. So there are, of course, the free frameworks that we will be discussing shortly, functional Java and Guava and Lambda J. But there are also tons of others like Totally Lazy, Offer J, and Jedi. So there are a lot of options for us. And just for those who are interested, Spring 4 will also be released later this year, hopefully. And it will also support first-class functions or support for Lambdas, since Java 8 will have support for that as well. So if you want to read up more on the support for Spring, you can read on the link here presented on this slide. Okay, Mattias, why don't you talk a little bit about the domain?
Yeah, soon we'll start presenting different use cases and how we can implement them using the different frameworks that will be part of this presentation. So imagine that you have a group of people or a group of persons, and each person has 3 different properties. First of all, a person has a name. Secondly, a person has a gender. Obviously, that's male or female. And lastly, a person also has an age. And using these properties and functional programming, we will solve a few different use cases. First, we would like to find the age of the youngest person. We will find the age of the oldest person. And we'll also, for some reason, be interested in finding the name of the oldest person. Or if we may be interested in finding the name of all the females in the group that we have. And the final use case is calculating the age of all the persons that we have. And starting off, Johan will tell us how this will look like using functional Java.
Yeah, sorry about the delay there. Yeah, functional Java is a framework that is very much inspired by Scala, in my opinion. So if you're used to Scala, you will probably recognize some of the naming conventions and concepts used in this framework. It's also very rich on features. So there's a lot more to functional Java than what we'll show here in this presentation. It requires Java 5, so it should work for most of you guys out there, I assume. And what all of these frameworks do is to simulate something called first-class functions. And this is something that we currently do not have in Java. We will get that with Java 8, but currently there is no such thing in Java. And first-class functions is a way that you can use as a programmer in the language to reference functions and use them as arguments to other functions. This is also called higher order functions. So functional Java simulates first-class functions or higher order functions by using this abstract class called f. This f class takes 2 generic arguments, a and b, and it has one method called f that takes an instance of a and return an instance of b. And we'll see how we can use this in our first example. So the first use case that we're going to solve is to find the age of the youngest person. And we imagine that we have a list of persons. This is the first line that you can see here. This is, your normal Java collection, nothing special. And as you probably know, normal Java collection or list doesn't have these methods like map, filtering, and folding. But functional Java, the functional Java counterparts have this method. So the first thing we have to do is to convert our normal Java list to a functional Java list. And we do that by calling this method here, fj.data.list.issuable list, and we pass in our normal Java list of persons, and it will return a functional Java list of persons. So now we can actually call this map method. And to the map method, we now pass an instance of this class that we saw in a previous slide. We create an anonymous inner class, and as an argument, we accept persons, and we return integers because we want to convert each person object to its age. So this is actually what we do here. So the only thing really of importance is that we call person.getH. And this function will be applied for each person in the list. So after we have finished iterating over the entire list, or actually when functional Java has finished iterating over the entire list, we will have a new list of integers representing the age of each person. So that's the first step to solving this use case in a more functional kind of way. Next, we could actually use the fold or reduce operation that Mattias was talking about previously, but functional Java has some predefined methods built into the framework. One of these methods is the minimum method. But in order for the minimum method to know how to, or to determine which of the integers that is the smallest one, we pass in another function that is also defined in functional Java called an int_ord. So functional Java has some predefined functions for your basic data structures or types in Java. So they have support for strings, integers, floats, etc., etc. So this int_ord, what this function does is that it knows how to sort elements by natural order. And natural order of ints means that if we have like a person that is 20 years old and another one that is 30, it will know that 20 is less than 30 because that's the natural order of ints. It says that. So after we have finished executing this method here, it will actually return the youngest age as an integer. But as you can see here in this example, it's not very pretty. So it's actually quite bloated. So we should do something about this. So one thing that we could do is to simply extract the anonymous in a class that we had and just attach it to a field. So here we have declared a static final field called h that we now can reuse in different use cases if we like to. What we also can do, just for syntactic sugaring, is to create a method, and this is a method that we create ourselves. We create a method called with that accepts any Java iterable, and it converts this Java iterable into a functional Java list. So this is just to make the code less verbose. So if we revisit the same example again, it can actually read something like this. So this is the very same example that we had on the previous slide, but now it reads a whole lot better in my opinion. And also what's cool about functional programming is that now that we have these basic building blocks, we can actually reuse them to solve other use cases. So all we need to do to solve the next use case, finding the oldest age, is to change the minimum method to the maximum method in functional Java. So that will actually return us the oldest age that we have in our list of persons. So that's actually quite simple now. And likewise, finding the name of the oldest person, for that we can also use the maximum method. As you can see here, because the maximum method and minimum method, they don't only work for the primitive types like integers and strings. You can also use them for objects. So in our list we have person objects, and so we create an instance of ordering in functional Java, and we call that h_order. That is what you see here. We won't go into the details of how it's actually implemented, but you can compare this to your normal Java comparator. Then you have a fairly good understanding of how it looks like. I think it's quite sad that they don't use the standard Java comparator because they have their own. I don't really know the reason for that, but yeah, if you write this, it will work. So what the maximum method will return now is the person that contains the oldest age. And from that person, we simply call the getName method, and that will return us the name of the oldest person. So that is also fairly simple to do. In the next example, we wanted to define the name of all the females in our list of persons, and we can do that in functional Java like this. So let's look at it in a bit more detail. So the first thing we want to do is to find a subset of all the persons, right? Because we're only interested in the females. So we do that by using a filter operation. And here we have defined a method called gender that we can use for if we, for example, want to reuse this filter operation and instead filter out all the males. We could reuse the same gender method here. So the method is called gender, and it accepts a gender. This is the enum that Mattias showed before. It's a part of a person. And we return an instance of f again, but this time it must return Boolean. Because, as you can see, we call person.getGender and see if it equals to the gender that we passed into our method here. And if that evaluates to true, a Boolean will be returned, and functional Java will retain this person. Otherwise, if the f method here returns false, it will be discarded. So once we come here to the next step in this example, to the map operation, we only have females in the list. So now we want to get the names of all the females, so we create a new instance of f again and apply that to the map method. And this is very similar to the age function that we created before, but instead of returning the age, we simply return the name. And yeah, now we've actually found the name of all the females. So that is nice. But perhaps you notice something here, that the last step we do is to call the toCollection method. Because remember that we have transformed our list of persons into a functional Java list of persons. And if we're interested to get a normal Java collection back after we're done, we need to convert it back into a Java collection. And we do that by calling the toCollection method. All right, so an example that will be returned here is, maybe the names or something like this: Linda, Jane, Mary, Susan, Linda. So you can see that we have duplicates here in the list, and there are, of course, ways in functional Java where you can remove duplicates if you like as well, but we won't go into that now. The last use case that we want to solve is to find the total age of all the persons. So that is a little bit interesting. So, yeah, we start off by doing a map operation again to age, so that we have a list of integers representing the age again. But what's interesting now is that we will make use of the full left operation in functional Java. And let's look at it in a bit more detail. The sum function here is something that we create ourselves. And you can see that here as well. So the sum function we defined using an f2. And f2 is, well, virtually the same thing as f that we saw on the previous slides, but f2 takes two arguments. F only took one argument and returned a single argument. F2 takes two arguments and returns a single argument, etc. Because here, if you look at the first arguments here in the f method, it's called accH, which stands for accumulated age, and that's an integer. And the second parameter is also an integer called age. So if we go through this example one step at a time, when we are at iteration 0, the accumulated age will be 0. And it will be 0 because we passed 0 to the full left method as the second parameter. And the age parameter in the f method will be equal to the age of the first person. So let's say that the first person is 10 years old. Then we will have a cumulative age of 0 and the current age of 10. So we add these two together and we will return 10. So in the next iteration, the accumulated age will be 10, and the current age will be perhaps, the current age of the next person will be perhaps 20, and that will return us 30, which will go into the accH in the next iteration. This will continue throughout all the persons in the list, and when everything is, when we've iterated over all persons, it will return actually the sum of all ages. So yeah, that's pretty cool. But as I said, with functional Java, they already have some predefined functions built into the framework for dealing with primitive types, such as integers. So they have actually a method for summing integers already built in. So if you use the for left one method in functional Java and pass in the integers.add function, it will actually do this for us, so we don't have to write this sum function ourselves. Okay, so that was actually it for functional Java. What we like about functional Java is the naming conventions. And that is because it follows the syntax used by other languages such as Haskell, ML, and Scala, and F#, which means that mapping is actually called map, for left is called for left, and filter is called filter. So that is quite nice in our view. It's also very powerful. What we've shown here is only the tip of the iceberg, so to say. They have a lot more features than what we have presented here. It supports parallelism, so you can do parallel map, for example. And because it's so powerful and it has so many concepts, it could be a good learning platform, and also because of the naming conventions. I find that it's a pretty good framework for getting to know and learn these functional concepts. It's also mutable and lazy and everything like that, or everything that you would expect in a framework like this. The drawbacks of functional Java, in our view, is that it uses these non-standard collections. So if you're not willing to convert your entire application to use the functional Java data structures, you have to convert back and forth from normal Java collections to the functional Java collections. And that is it's not very efficient. It wastes both CPU and increases memory consumption. Also, the API is a bit inconsistent. For example, you saw here the functional Java list. They also have functional Java array and iterable. And they all have some different overloaded methods that I cannot really see why they shouldn't have the same kind of overloaded methods in all these different data structures. And also the powerfulness of functional Java, it could be a drawback as well, because if you start using this in production, it could be quite hard to read the code after a while if you start to really digging into functional Java. And also, perhaps your colleagues won't be able to understand what you write. So you should, of course, always be careful not overusing any of these frameworks here. And also some of the method names are not always obvious. Perhaps if you know Scala, these method names perhaps make sense to you. But _1, like this, it's how you get the first value out of a tuple in Scala. But I don't really like this method name. And a little word of warning, if you find yourself using functional Java and using this F class with up to 8 parameters, perhaps there is a better way to solve the problem, or at least you should look into alternatives. All right, so that's it for functional Java. Let's move to the next framework of LamdaJ.
Yes. So now we can see how it will look like in LamdaJ. First of all, LamdaJ requires Java 5, which makes it pretty good, even for old legacy code, that if you have to do some refactoring there and you would like to learn some functional programming. The first thing you notice here is the implicit function creation. You see here you have, in the Lambda class, you have a static method called on. And to this on method, you pass in a class, and LamdaJ will actually create a proxy for you based on this class. So you can imagine that you have the A class here, and you have a getB method on the A class. And this would actually create a function that can be reused for when iterating across collections. LamdaJ also uses hamcrest matches, and if you're not familiar with hamcrest matches, I suggest that you go and read up on them. They are very frequently used when it comes to unit testing. And what they do is provide a set of matches or predicates that allows you to verify different states. For example, it can check if an instance is of a particular class. It can check if a collection is empty, if a certain instance is inside a collection, if there's certain string operations, and so on. So that is a sort of bonus on this webinar, that go and check up on Hamcrest matches if you have not already done so. So moving on to the first use case, finding the youngest age. And this is what it looks like using LamdaJ. First of all, we have a with method. And in contrast to functional Java, the with method is actually provided by LamdaJ. The purpose, though, is the same. The persons is an instance of a list using our normal Java, but we need to convert it into a LamdaJ list so we can access these functional functions that do not exist in the normal Java collections. So using this first with persons, we convert the persons list into a LamdaJ list. And now we have access to a min function. And the argument to a min function is another function that is created implicitly using this LamdaJ construct. So here we actually have the conversion from a person to its associated age. So we pass in on person.class, which creates the function, and then we call the getAge method on that. And this will actually iterate across the entire list of persons, and the min function will keep the result of the youngest age. So when the statement completes, we left with one single age, which represents the age of the youngest person. So now we would like to find the age of the oldest person. And all we have to do now is replace the min function with a max function. Because that is the beauty of all the functional programming. You see this in all our examples, that once you have identified the building blocks that you need in a functional way, you can compose them together and solve different use cases. Third use case is finding the name of the oldest person. And rather than using the max function that we saw before, we now choose to use the select max method. The difference is that max method returns the converted value, but the select max method will actually return an instance of a person. So as an argument to the select max method, we yet again use the onPerson.class.getAge to transform a person to its age. But now, since we are left with an instance of a person, when that method completes, we can call the getName method on the person instance. And consequently, we're left with a name of the oldest person. Next use case is to find the name of all the females. And what we see here on the first line is that with the retain function. That is LamdaJ's way of telling us to filter. So a bit of different naming here, but it does the same thing, but you have to, when you look in the API, you have to remember that you're looking for retain and not filter. To the retain function, we pass in a utility function by LamdaJ called having. And having actually is an implementation of a Hamcrest matcher. So the attribute to the Hamcrest matcher is the gender of a person. And the gender of a person we can extract using this function creation that we have seen so many times now. And the thing we would actually like to compare on is once we have extracted the gender, we have a predicate that evaluates it true if that gender is female. So after this first line evaluates, we now have a collection containing only the females. And since we're interested in the names of the females, we have to convert each person instance to its associated name. And that is a mapping operation. And mapping operations are called map in LamdaJ. And how do we do about to convert a person to the name? Well, we have the same on construct again, but this time we call the getName function. And as a result, we have the same a list of only females. And the same as before, we have duplicates in the list, but there are ways to handle that if you're only interested in just the names and get rid of the duplicates. The last use case is to find the total age of all the persons that we have. And starting on the first line, we begin with extracting the age of the persons. And extract is the same as map. So from having a list of persons, after the first line completes, we have a list of integers representing the age of the persons. And on that, we perform a reduce operation, and reduce operation is called aggregate using LamdaJ. And what you see now is actually the first anonymous in a class in LamdaJ, because so far, because of this implicit function creation using the on method, we have not written any anonymous inner classes ourselves. But in order to solve this problem, now we need to create an anonymous inner class. So the class that we would like to create is called pair aggregator. It's provided by LamdaJ. And there are two methods that we need to override. The first is empty item. We choose to return 0, because you can imagine that if you have a list of no persons, then of course there will be no age. Or if you only have a list of one person, that is your starting value, because to sort of initialize the accumulated age. The second method we need to override is the aggregate age. So similar to Johan told us before, when you start a list, you have an accumulated age of 0, and if the first person is of age 10, the aggregated age will be 10, and if the second person has the age of 20, next time we call the aggregate function, the accumulated age will be 10, the age will be 20, and the aggregated age will be 30, and then we keep iterating across the list until we have calculated the age of all the persons. And LamdaJ also has a convenient function for this, for primitive operations. As you see here, you have the sum function, which can operate on any Java number. And the number we're interested in here is a function that we create by using the onPerson.class.getAge. So what do we like about LamdaJ? It can be less code to write. We don't have to write any anonymous inner classes because we use this on construct. It uses Java standard collection, or extends them. So a LamdaJ list extends from the normal Java list, and similar for all the other type of collections. So that means we don't have to convert back to the normal Java list after we finished. It supports the basic stuff. It has less details or less complicated functional use cases, if you say. But as you see here with all the examples, LamdaJ has support for lazy evaluation. And if you're interested in LamdaJ and would like to know about more complicated stuff, the LamdaJ also has the implementation of closures that we did not show here, so that you can go and read up on how that can look like. Some disadvantages we found with LamdaJ is because this onConstruct, because of its proxy generation, it does not allow us to use final classes. So, which means if you have the person class in our case cannot be final, because obviously that fails when we try to create a proxy of it. We think that the naming conventions are a bit unlucky. We use the extract instead of mapping. We use aggregate instead of fold. We have to retain instead of filter. There's some performance overhead using LamdaJ compared to imperative Java, and that is because of proxy generation. If you write long-chained LamdaJ expressions that you can imagine you convert from one thing, filter from one thing, and then reduce, it may be hard to read sometimes because you have all these class objects that you have to pass into the on methods every now and then, and that's, yeah, it will be verbose after a while. And another disadvantage that we found is that the latest release of LamdaJ has not been pushed to Maven Central. There is an issue for that in the bug tracking system, but it has been there for more than a year now, so that's a bit unfortunate. So that concludes the LamdaJ section, and now we continue with the Google Guava.
Yes. So the basic building blocks of Google Guava is a function and a predicate. But Google Guava was also previously known as Google Collections. So it's a collection from Google. And there's a lot more to Guava than just, this functional aspect. So they support concurrency, events, queuing, caching, and various other utilities. And Guava currently requires Java 6. And as I said, the two building blocks of Guava when it comes to simulating functional programming is the function interface and the predicate interface. And the function interface is very similar to this F class that you saw in functional Java, except that, well, in functional Java it was a class called F. Here is an interface called function. And but other than that, it's pretty much the same. But they have this special kind of a function called a predicate that always returns Boolean. And yeah, you can imagine that you would use this in filter operations, etc., where you want to find a subset of a collection, for example. So let's see how we solve our first use case again, but now using Guava. So Guava has an API called Fluent Iterable, which we make use of here. And this Fluent Iterable API have a method called from, to which we pass our normal list of persons again, and it will be converted to this Fluent Iterable that Guava provides. And an important thing here is that it's actually, yeah, I probably said converted here, but what actually happens is that Guava wraps the normal Java collection. So you don't actually have the full conversion that we had in functional Java, which means that Guava will be much faster than functional Java in these cases. The next thing we do is, again, we want to map each person to its age, and we do that by using the transform method in Guava. So mapping is called transform in Guava. That's important to know. And then we want to find the minimum age again, or the youngest age. But Guava does not provide a method or function for this. They don't provide a minimum or maximum function. But if we still want to, solve this use case in a fluent way using the Fluent Iterable API, there is a little workaround that we can use, and that is to convert our list of ints into a sorted list. And it's also immutable as a bonus. And as an argument, when we sort a list, we pass in ordering.natural, which is also a static method that is provided by Guava. So that we learn the same thing that we learned in when we talked about functional Java, in regards to natural ordering, it applies here as well, of course. So here, after this toSorted immutable list method has finished executing, it will return the list of integers representing the age in natural order. So all we need to do now is to get the first element, and that will actually return us the youngest age. So that actually solves the first use case in Guava. So again, now we have these basic building blocks again. So the only thing we have to do to solve the next use case. Oh, sorry, I forgot one thing. Let's look a little bit closer at the age function. So the age function, this is how it's implemented in Guava. And as you probably can see, it's very similar to what we saw in functional Java. But instead of using the F class, we use an anonymous inner class of function. But the point of interest here is that we call person.getAge, and this function will be applied for each element in the list again. Okay, so now we have the building blocks ready to use to solve our next use case, and that is finding the oldest age again. So the only thing that we need to change is the natural ordering to reverse natural ordering, which of course means that the first element in the list of ints representing the age will be the oldest age. So that's it. But then solving the third use case here turned out to be a little bit trickier. It's actually turned out that we couldn't actually find a good way to solve this use case using the Fluent Iterable API that Guava provided. But we managed to find a workaround, and a workaround that was still, in a fluent manner. But we had to use the from method from the ordering class. This is the same ordering class that we used in the previous slide to get the natural ordering, etc. And to this from method, we pass in a person age comparator. And here it's actually a real standard Java comparator, so it's nothing special. And that is quite nice, actually. And then now we actually have a max method to which we pass our normal Java list of persons. That will actually return us the person instance that contains the person with the highest age, and we simply get the name in the last step here. But if we look at this example here, to me this is a little bit reversed. I would prefer if we passed in the list of persons to the from method and the comparator to the max method instead. That would seem a little bit more natural to me. So I don't really know why they have chosen to use this API. Anyways, the next use case, finding the names of all the females in Guava, it looks something like this. So again, we use a filter operation, and we create this gender method again, very similar to what we did in functional Java. But here you can see this special function that we were talking about before, the predicate. But other than that, it's very similar to what we saw in functional Java. So again, we just pass in the gender enum, and we check that the person, or if the person has a gender equals to the gender that we supply to the method, it will be retained, otherwise it will be discarded. So in the next step, we transform the persons that we found to its name, and you've seen how that looks like before as well. And if we run this, you will see that we get duplicates here as well, but you can if you want to get rid of the duplications, you can simply convert this into a set or something like that, and you will get rid of the duplications. But one important thing here to note is that we don't need to convert what's returned from the transform method back into a Java iterable if we don't like to, because functional Java just returns a standard Java iterable. So this is quite nice. So we can, pass this iterable along to other methods if we like to. So the last use case in Guava turned out we actually failed to solve it using Guava. And the reason for that is that they do not have a method called fold or reduce. And there is an issue added in the Guava list for this, and it was added in August 2009, but they have decided not to take action on this. So you can probably read up on the details there if you like to. Okay, to sum up Guava. One of the good things with Guava is that you may already use it. So this means that if you already use it for other things like the event handling or caching, etc., then why not go ahead and start experimenting a little bit with the more functional aspects of it. Well, what we also like is that filter was actually called filter. And another big plus is that it uses these standard collections, and it wraps your standard iterables or lists. And that is really nice. On the negative side, if all you're interested in is a framework for doing functional programming in Java, then Guava could be considered bloated because it has all these other utilities like we talked about before. But if you need this other stuff, then of course Guava is not bloated. Also, the naming conventions, we had to, the map method was called transform, etc. And as it turned out, we couldn't solve actually our last use case since there was no reduce or fold method in Guava, at least not in the Fluent Iterable API. And there was also this confusing entry points. We couldn't do everything that we wanted from the Fluent Iterable API. We had to revert to use the ordering API to solve our third use case, I think it was. All right, so that concludes Guava. And Mattias, why don't you summarize the presentation so far?
The key takeaway with this presentation is that functional programming is here. Well, it may not be here because Java 8 has been delayed, but that is no reason for you not to start thinking in a functional way and start using the frameworks that are out there to learn how to program in a more functional way. It will change the way you think and solve problems in the future, I promise you. As we've seen, there are quite a few frameworks and libraries that support functional programming on the JVM. We presented 3 different here, and there are a few others out there as well, so that you can use. One question that we often receive is, will there be a performance overhead? And yeah, there will be. It's the hard truth. Because what we've seen here, you have the conversion between, for example, in functional Java, conversion between Java collections and functional Java collections. We've seen the proxy creation using Lambda J, and there is a few clock cycles there that you have to spend if you try to write functional today. But the important thing to know is, does it really matter to you? If you're a graphics programmer and trying to chase those high FPS numbers, I would advise against putting these frameworks inside the innermost paint loop. But if you're a server programmer and you have remote network calls, the network latency will be much, much bigger than the overhead associated with these frameworks. Likewise, if you're a GUI programmer and you're waiting for user interaction, the overhead you see using the functional frameworks is, well, several orders of magnitude smaller. So that is really not an excuse in those use cases for not using these frameworks. And of course, once we get Java 8, the latency, then you probably stop using these frameworks and using the native Java 8 Lambdas instead. And then, of course, there will be no performance overhead. And lastly, a disclaimer provided by the Guava teams. And on the web page, they state that when you go to preposterous lengths to make your code a one-liner, the Guava team weeps. So I guess that is what happens with all programming. If you have a method call that is 50 or 100 lines long, turning them into a one-liner that is, 1,000 characters long instead, does not make your code more readable. So our advice is go home, read up on this, start using it, and you will see that you will develop as a developer, and these things will help you when you adapt to Java 8. So that pretty much concludes our session. And if you have any questions, feel free to ask.
So if you have questions, folks, please just enter them into the Q&A panel on the WebEx control panel. It's in a little drop-down menu up top. If you guys have any questions, so we'll leave the line open for a minute and see if folks have questions. If not, we'll conclude the session, and we'll be replaying this session on our YouTube channel. So you can share this with your coworkers or come back and view it again at a later time. That YouTube channel is youtube.com/SpringSourceDev. Again, youtube.com/SpringSourceDev. Also, we will be having a few other webinars this month, so if you'd like to come back and join for another webinar in the program, we're going to be having another talk on July 30th about Spring with Cucumber for doing test-driven development and behavior-driven development on July 30th with Hemant Joshi. So please come back and join us then. And if there are no questions, I think we can close the session.